When temperature and pressure are held constant, what happens to the volume of a gas sample when the number of moles is increased? Remember that volume is proportional to the number of moles, so that means that they increase and decrease directly. Therefore, if the volume of a gas sample is what's being asked about, moles are increased, the volume will increase. The next question. A typical automobile tire has a volume of 10 liters and holds 1.12 moles of air. What is the tire pressure at 273 Kelvin? For your answer with 3 sig figs, do not include units in your answer. So this problem, we've got moles there. So N is equal to 1.12 moles. We're given a volume, 10 liters. We're given a temperature, 273 Kelvin. We've given 3 of the measurable quantities of a gas. We can use PV equals nRT, the ideal gas law, to find out the other one. In this instance, it's asking for pressure. Substitute in. P is equal to N to 1.12 moles. R is a constant. It's on the periodic table that you'll be given for an exam, liters atmosphere per mole Kelvin. The temperature is 273 Kelvin. And the volume is 10 liters. If I do all that math correctly, using 3 sig figs, that's going to be 2.50 atmosphere. Units cancel. You're left in units of atmosphere. The next question. Indicate whether each molecule is capable of intermolecular hydrogen bonding. Enter either yes or no as your answer. To hydrogen bond, you must have either an NH, an OH, or FH bond. You have to have that present in the molecule in order to get intermolecular hydrogen bonding. NH3, yes. N2, well, there's no hydrogen, so no. HI, there is a hydrogen, but there's no nitrogen, oxygen, or fluorine, so no. HF, yes. Consider the following materials and their specific heat capacities. So water, sand, silver, iron. So there we go. Each sample absorbs 10 joules of energy. Which substance will have the lowest final temperature? So recall, the higher the heat capacity, the more energy required to change the temperature. Well, the highest heat capacity that we have, for what's listed, is water. Therefore, water will have the lowest final temperature. 10 joules would not raise that temperature as much as the other materials. Next question. Select the two true statements. So this question is asking you solubility rules. So CHE and GEA. A, bromide is a halide. Generally they're soluble, but when paired with mercury, silver, lead, they are not. Okay, so mercury 2 bromide is insoluble in water. That is true. The next one, NO3 is nitrate. They are generally soluble. There are no exceptions. So that statement is not true. So mercury 2 nitrate would be soluble in water. Well, nitrate, silver nitrate would be soluble in water. Again, no exceptions. And then D is true. Sodium is a group 1A metal. No exceptions. Got to know your solubility rules. CHE and GEA is a good way to help remember them. How many grams of glucose are contained in 32 milliliters of a 5% weight to volume glucose solution? Report your answer with two significant figures and do not include units in your answer. So 5% weight to volume. That means that you can say that you've got 5 grams in 100 milliliters of solution, or vice versa. 5 divided by 100 is 0.05, turns into a percent, would be 5%. So we've got 32 milliliters. We would use the conversion factor on the left, get units to cancel. If I do that math, that would contain 1.6 grams of glucose. So 2 sig figs, 1.6. Next question. You dissolve 11 grams of sodium chloride in water and the solution has a volume of 659 milliliters. What is the molarity of the solution? The molar mass of sodium chloride is 58.44 grams per mole. So the formula we need is molarity, big M, moles of solute divided by liters of solvent or solution. Here we've got, to get moles of solute, we've got 11 grams of sodium chloride, and we know the molar mass is 58.44 grams in 1 mole. So 11 divided by 58.44 is 0.188 moles. Then liters of solvent, the volume's given milliliters. A 1,000 milliliters are in 1 liter. So 0.659 liters. Plug in and solve. If I do that math correctly, answer is B. 0.286 molar. The next question, what is the molarity of a stock solution if 647 milliliters was diluted to 5.7 liters to make a 1.2 molar sodium hydroxide solution? So it's a dilution, means M1V1, M2V2 is needed. So we've got, what is the molarity of a stock solution? 647 milliliters was diluted to 5.7 liters. So V2 is 5.7 liters. M2 is 1.2 molar. V1, 647 milliliters. So the question's asking for M1. As seen previously, you've got to convert that to liters. Divide by 1,000. That would be 0.647 liters. It would be that value. So we solve for M1. So 1.2 molar times 5.7 liters divided by 0.647 liters. Divided by 0.647. And that rounded 10.5 is what you would get, but it's multiple choice. 10.5 would round to 11 molar. Next question, which solution will have the lowest freezing point? The answer is C. This compound is covalent. Therefore, it doesn't ionize or dissociate in water when it's dissolved. So this would only have 0.10 moles of solute. Same number as is. Sodium chloride would dissolve into 2 particles. So that would be times 0.10. So 0.20 molar for colligative properties. 3 particles. Sodium bromide would be 2 particles. So calcium chloride would lower the freezing point the most of those 4 solution choices. What is the melting point of a solution that has had 4.6 moles of NaCl, sodium chloride, added to 1 kilogram of water? The change in freezing point is minus 1.86 degrees Celsius per mole of particles for 1 kilogram of water. So 4 sodium chloride, when it dissociates, when you dissolve it in water, you get a sodium cation and a chloride anion. So you get 2 moles of solute, or of particles. So if you've got 4.6 moles of NaCl, you get 2 moles per 1 mole. And then the temperature will drop 1.86 degrees Celsius per 1 mole. There, we've got 1 kilogram of water, so we don't have to do anything with that. And if you do that math correctly, you should get a temperature decrease. The new freezing point of that solution is minus 17.1 degrees Celsius. The next question, label each reactant and product as an acid or base. So if we look at the changes here and here, you see that NH3 gains H plus to become NH4 plus. So a proton acceptor or gainer is a base. And then if you look at water, hydroxide, H2O lost H plus to become OH minus. It donated a proton. It lost it. It's an acid. And then the terms OH minus is the conjugate base, but the question is just to be more specific, so just a base. Then NH4 plus is the conjugate acid. The question's asking for just the acid term. If you were to run the reaction backward, NH4 would become NH3. It would lose a proton and be an acid. The next question. What is the pH in a solution with an H3O plus concentration of 6.6 times 10 to the minus 11 molar? So pH is the negative log of the concentration of H3O plus. So we just take the negative log of 6.6 times 10 to the minus 11 molar. And that pH is going to be 10.2, 10.2. Next question. What is the concentration of OH minus hydroxide in a solution with a pH of 1.8? So for this question, the pH scale is 14. So you can know that the pH plus pOH is equal to 14. Roughly. So you can do that math. The POH is going to be equal to 14 minus 1.80. 12.2 is the POH. So from that, the concentration of OH minus hydroxide is equal to 10 raised to the negative POH value. So 10 raised to the minus 12.2 be A. 6.3 times 10 to the minus 13. Molar would be the concentration of hydroxide. The next question. What is the concentration of H3O plus in a solution with a pH of 5.54? This is very similar to the previous problem, where you've got the concentration of H3O plus is equal to 10 raised to the negative pH. So 10 raised to the negative 5.54 it's going to be A 2.88 times 10 to the minus 6 molar. That would round to 2.9. The next question. What volume of 2.54 molar sodium hydroxide is required to neutralize 4.72 milliliters of a 1.67 molar HCl solution, or 1.67 molar hydrochloric acid? So for this problem, you have to have a balanced chemical equation. So we've got sodium hydroxide reacting with hydrochloric acid. So the products for any acid-base reaction is water and a salt that sodium's a cation, +1, hydroxide, the whole thing is -1, proton is +1, chloride is -1. Those pair, opposites attract. NaCl aqueous. And it's balanced. One sodium on the left, one on the right, one chlorine on the left, one chlorine on the right, or chloride. The equation's balanced. So from there, the numbers in the problems, it's asking for a volume of sodium hydroxide. So we need to figure out, for this, for titration, you're given a volume of X. You can go to moles of X to moles of Y to volume of Y. using the molarities, go from moles to volume and vice versa, and the balanced equation to go from moles of X to moles of Y. So we've got 4.72 milliliters of the HCl solution. There's 1,000 milliliters in 1 liter. And we know that this is the same as 1.67 moles in 1 liter, or 1 liter is 1.67 moles. Any molarity, you can get that type of conversion factor. To get units to cancel, 1 liter knows to go on the bottom, 1.67 moles of HCl needs to go on the top. Then you have 1 mole sodium hydroxide per 1 mole of HCl. Cancel. And then the molarity of the sodium hydroxide, you've got 1 or 2.54 moles of sodium hydroxide in 1 liter. Do all of that math, you should get 0.00310 liters, but that's 3.10 milliliters. And that's what the question, the unit the question is asking you for. You have to multiply that number by 1,000, and that'll get you to milliliters.